Welcome to Digital 360 Summit 2020. We are the premier event for senior executives driving industry digitalization, decentralization, and decarbonization. 2020 edition is a free virtual event via Zoom. The dates are August 18th, 19th, and 20th, 2020, and August 25th, 26th, 27th, 2020. We want to thank our sponsors, Texas State University, Greater San Marcos Partnership, and Cedar. This year's edition has 70 speakers from amazing companies like NASA, Intel, SAP, CPS Energy, Brazos River Authority, Katera, Direct Energy, City of Austin, Aclara, Dell, Engie, Exelon, Oracle, Tesla, General Motors, TXDOT, Vistra, Siemens, AT&T, National Grid, Itron, City of Los Angeles, Austin Energy, City of Colorado Springs, and Hunt Energy Network, and over 1,000 attendees. The program has 16 keynotes and 11 panels, followed by 11 white papers and 28 videos. The event covers multiple industry verticals like networks, energy and utilities, buildings and infrastructure, water and wastewater, public safety and new financial tools, smart cities, sensor and edge computing, big data and software, smart mobility, new regulations and business models, space and smart factory, and Industry 4.0. We are also introducing Texas State Cedar, a new industry research consortium focused on connected infrastructure research enabling big ideas and the topics covered in each of the panels. We at Texas State, Star Park, Cedar, the Greater San Marcos Partnership, and industry partners are focusing on building 9 living labs to transform applied research and economic development with the goal to delivering one digital world.
Welcome to day 5 of the Digital 360 Summit 2020. We're delighted you're here. We know that it takes a little bit for the audience to jump on. So as you guys come in, hopefully some of you saw the opening video. I do have a follow-up on Cedar that I want everybody to see before we jump on and introduce our keynote speaker. So let me do that real quick and take the opportunity to show you this video that explains what the Texas State Cedar Consortium related to connected infrastructure research is all about. So here we go. It's a quiet video. Turn up your volume. Welcome again. Delighted that you're here with us. Let me introduce you without further ado to our keynote speaker for the Big Data and Software session. Our keynote is Stefan Wolf, who is a Global Vice President on Go-to-Market Execution for Utilities at SAP. Maybe his title has changed recently, don't know, but we can ask him. Stefan, how are you?
Good. How about you, Andres?
I'm doing great, Stefan. So now what we want you to do is take over the screen and share your slides, and off we go. You're in charge for 30 minutes.
Okay, very good. Let me see if this works out.
We see it.
Okay, can you see it full screen?
Absolutely. Thank you.
Okay, perfect. Yeah, thanks, Andres. Thanks for the introduction, and thanks for having me here at this wonderful summit. And yes, my title has changed at SAP. I think we have a nature of changing names and titles on an ongoing basis. So before I was doing solution management, now it's called go-to-market execution. At the end of the day, here in the unit I'm part of, the IBU, the Industry Business Unit, we are responsible for the thought leadership at SAP for the overall solution portfolio for utilities in there. So I'm excited to talk to you today about big data and software. Little bit disclaimer, our lawyers make sure we're not getting ourselves and the company into trouble. So if I talk about stuff which we have not really shipped yet, that might change at any point in time. Yeah, before I go into the details of big data, I wanted to put this a bit in context. And I wanted to start out here with the industry trends we are seeing, because I think they are really key to understand not just the big data, where they're coming from, but actually what we think we as an industry can do with that. And we have grouped this by 4 main areas. So one is assets. Here we see things like the renewables, which are popping up all around the world as a more and more becoming major source of energy, both in the utility-sized facilities, but also in the small-sized residential facilities, which of course cause not just problems in regards to having to the need for additional transmission lines, but also challenging the distribution network with a two-way flow of energy in there. Other aspects here on the asset side, we see more and more virtual power plants being used again, which require the capability to manage those, to put them at good use. So just a few aspects here on the trends we see on the asset side. Let's move forward to the energy and markets. So obviously a lot of utilities already using smart meters out there. Here we see an increase in the data volume, the data collection, not just because we're going to smart meters. We actually see that in some markets they're going from hourly to 50-minute to 5-minute intervals. At least they're discussing that. We see now with solar on the rooftop, with maybe a charging station out there, even more than just the main meter producing energy data on an endpoint level, but also we see all the energy data which is collected from the grid, from the smart grid, about the commodity being provided, being run through the distribution network, and all of that drives also the challenges on the settlement and balancing side. For all the energy streams out there, leave alone the competitive markets, the deregulated markets where you have multiple market players out there, which all need access to the energy data in one way or the other, making it more complicated with ever-increasing security and data privacy rules out there. Moving on to the customer. Customers these days are worlds away from the old utilities customer, from the ratepayer of times past. Customers expect to be treated and taken care of, like they seeing it happening from folks like Amazon, who from companies who understand them, like Starbucks out there, who know what they want, what they use, who provides them offers and possibilities, and serving them at their need every time, anytime, any channel the customer chooses. And the aspects mentioned before, like renewables, like electromobility, become more complex. Product portfolio utilities have already available for customers, which continues to increase. And the last area here where we see, which is challenging utilities, is the whole service area, service providing to the customer, whether it is the typical field service reaching the customer, whether the service around additional electric or other commodity-related services, again, e-mobility, solar, other renewables locally available to the customer, or even services above and beyond, which could be offered to the customer, which we see definitely already coming in the deregulated markets, but also in regulated markets, coming more and more of interest for utilities to broaden their portfolio. So it's a perfect storm for utilities already. Out there in all of the major areas of the business, there are challenges, there are changes, and then we see that beginning of the year we got an introduction here of a new player in the market. So COVID-19, of course, took center stage and disrupted the industry really from the ground up. Utilities, being an essential business, had to continue to provide power to customers, gas and water, since we're all working from from home, it's becoming more and more important that we don't have outages, or that we have those outages at a very reduced time, and doing that with a limited amount of work being able to be done outside in the COVID-19 situation, with lockdowns, with social and physical distancing, need for PPE, made it even harder for utilities to do their work. But they did an excellent job out there to keep the lights on, keep the water flowing, and keep the gas available for heating out there. So it's an industry which is really challenged by a lot of effects which we see out there in the world. And let me just grab a few of those for these different areas to show where all this data is coming from, which utilities already collecting. On the asset side, we see the monitoring, not just the equipment monitoring, all the way through the distribution and transmission network out there. The commodity monitoring is becoming even more important these days. Again, the term smart grid, of course, is everybody's mind right now. But with smart grid, with monitoring the equipment, of course, you have to have communications as those need to be monitored and managed too. So an additional stream of data and a single set of sensors which is out there. Video and image feeds to use video, for example, drones out there to monitor equipment, images. Think about the possibility for customers to just send in an image of a broken pole, of a maybe blown up transformer, which you not just want to keep the image, but you maybe want to process that image and automated detection of which asset that is, where it is, what is the cause, and so forth. So just a few of the drivers here which we see on the asset side to adding to the data. On the energy and market side, already mentioned the increasing read frequency for interval data, the increasing number of assets which are being metered out there, multiplying the energy data, the more complex energy networks, again, thinking about the possibilities for virtual power plants, even for dynamic virtual power plants, where assets like batteries, whether it's wall batteries or whether it's maybe EVs at some point, can be combined together with renewable resources in a dynamic fashion to create a virtual power plant just for the time being. We see community-sized renewables. You can buy shares from renewable plants. Utilities are asked to mention that, to manage that. So which make it more relevant to have the detailed information about the energy flows, both positive and negative, available for that purpose. And again, already mentioned the data privacy and data security aspect here to secure the access to that energy information, to help the consumer stay safe and protect them from data spies, as well as from the company, also from any kind of liability here. Moving on to the customer, we see here smart homes and other behind-the-meter devices driving the possibility for data to gain insight into the customer's behavior. We see even in the mass market more complex products, whether they are time of use, flexible time of use type products out there. As you know, for example, California moved to a default time of use for the residential markets. So that adds to the data volume quite a bit out there. Term customer journeys comes to mind. What is the customer doing? All the marketing experts want to have all the information, social network data and so forth, to understand the customer better, to really serve the customer better out there. And on the service side, of course, we have the multitude of channels where we need to tap into the customer to stay on top of the information which is flowing back and forth here. Mention the complex service products. So again, just to mention a very few of the drivers here for big data in all these different areas. And as I was a software engineer at the beginning of my career, so I loved to have data. I loved to store data and then build my apps on that. And the easiest choice would be just to say, okay, we get data on the asset side, let's just store all the asset data so we have access to asset information. That is a very simple answer, but we all know this is not sufficient. This is not what is helping. And the reason why this is not helping other maybe satisfying the techno geeks like myself here to play with all the data is we actually want to drive business benefits. All these technologies mentioned before, all these data drivers actually have a place in there to help with the business. Whether it's on the asset side, to help to optimize the asset investment. I don't monitor the equipment just to monitor it. I monitor that to do predictive maintenance, to get away from scheduled maintenance, to get away from reactive maintenance once it's broken, to come to a place where I do maintain the asset when it's actually necessary, where I do replace it when it's cost efficient to replace it, and not because some schedule tells me to do so. Thinking also about COVID-19, using digital twins, drones, robots, and whatnot to not just maybe reduce cost, but also keep the employees safe out there, so they don't have to go out and monitor equipment. It doesn't have to be as challenging as maybe a wind farm in the Arctic Circle out there. It can be just like we're experiencing here in California, the wildfires, to inspect the transmission lines with drones, which is much more cost effective, much easier, as if you would have always to send a helicopter with people to fly out there to check that. So there are business drivers behind it. And I tried to list here just a few of these business drivers for the different areas, which are actually beneficial for the utility, because they either need to do this because of regulatory requirements, or because this is what they can do to improve their business, to, for example, in the energy and market side, to have a better forecast on the energy consumption. Again, looking at COVID-19, we're all working from home, so the consumption patterns changed quite dramatically. Most office complexes are still empty in major parts of the world out there. But at home, there is an increased need for energy, at least during the typical work week out there. So to stay on top of these changing energy flows, to provide the insights both for the internal planners and agents, as well as for external parties, you can use that energy data. But it's not just the energy data. You need to have information about the customer as well, maybe some asset information to make heads and tails of that information, to combine the insights in the energy with the asset information, to know what is actually flowing through that, what is the actual route the energy is taking, just as an example in here. Moving to the customer, of course, here we can use all that information to anticipate and preempt the customer needs, to provide next best actions to the agent or to the customers themselves in self-service scenarios, to help them with their usage, to provide individual guidance versus just standard plain recommendations, which are not tailored to the situation of the individual consumer out there. Earlier in the summit, there was also discussion about outcome-based products and service. So moving away from just selling kilowatt hours and kilowatt, maybe coming to a more customer-oriented set of products and services, where we can provide convenience, where we can provide security to the customer, and monetize that, and getting away from electrons or molecules, which often are not really the cost driver for the utility, but just a means to transport to the customer, and which helps then by going to outcome-based products and services to would be able to come to a more reliable revenue source for utilities and energy providers. Same on the service side, we can use that data to provide more tailored services, to understand how service delivery actually worked, to have end-to-end transparency through the service delivery, and improve almost in real time the experience of the customer, as well as the experience for the service agents out there. So the key message here is we need to get away from just looking at the data as a technical means, but as actually an enabler and support for business benefits. And it's not that simple either. Like I showed with those 4 data pods out there. Sorry for this very crude picture here. I don't want to spend too much time on that one. It's just to show that there is a huge number of systems out there. And I really just listed the main components here and used the starting letters A, C, E, and S to indicate where at least some of the asset, customer, energy, and service data is being located. So it's not one data pod out there. It's really already distributed, and to harmonize all the systems into one is obviously impossible. Same it is to just create one data pool where all the data is stored. We have to deal with the complexity here, which we see at utilities. And talking about complexity, I found this analysis here. It's from a McKinsey report. It talks about the cost for data, and it's not utility specific, so don't get too hung up with the exact numbers in there. They're probably a little bit different for utilities, but I think direction is there right, and definitely correct are the 4 main areas where costs are occurring with data. It's the sourcing to collect the data, it's the architecture, it's the governance around the data, and it's the consumption of the data. The sourcing, which is quite high here, I think is for utilities not that relevant because they're already collecting all that information. They spend already tons of money in the communication networks to collect that data. So that is probably on the lower end here, the annual spend. If you just look at the IT part, if the communication networks and so forth are already covered on the asset side. But architecture, governance, and consumption particularly are certainly where we see cost is coming in. And we see here also the potentials for savings out there, which are substantial in the architecture and the consumption side, by doing relatively simple things, by simplifying the architecture, by helping the engineers to be, the data engineers to be more productive, by maybe offloading data infrastructure, not to have to maintain everything on premise at the company, as well as on the consumption side to increase the report automation to help the data scientists, the data analysts to be more effective by making it easier for them to access the data. So what does that mean? Let me come here to a more simplified picture. So what we see here with the intelligent suite, from customer experience over manufacturing, digital core, people engagement, network spend management is an SAP display of the core components out there. If I look at the utilities, let me just assign those components here quickly. The digital core is where the ERP, where the customer information system is located. Asset management is distributed between the manufacturing part and the digital core. And to the left is the customer experience. Of course, we have call center, self-service, commerce, marketing, and so forth. And we have all the other systems out there which are supporting these solutions which are relevant for the overall business processes. So just to explain how that fits into that picture, because in the next one I really want to show what we see is the way how we can deal with big data, provide the business benefits, drill the oil from the data, and do it as a cost-effective way. It is by looking into a common platform which allows the data to be stored where it should be. So, for example, transactional data would stay with the transactional system. Historian data would stay with the historian out there, but you want to bring the data together, whether it's between the components I mentioned before, like asset, energy, and customer, whether it's between the different systems, to allow the data to be stored and managed in the right place, but having a possibility to combine that. And obviously realize we as SAP are not the only one who is providing that. The key message here is really we need to work as an industry on a platform platform level to provide access to a harmonizing platform for the data, and a common tool set to really help the data engineers to access all the data throughout the company. It, of course, needs to support not just the apps which are being built natively on that one, but also integrate third-party apps, whether it's through the standardized API layers, whether it's through tool sets to support those, to not limit the use of the platform to just one type of applications, but really support all the applications which we need. The use of virtual data models is very important. I would like to point that one out because, as I mentioned, we cannot just copy the data from place to place to place and making big data even unmanageably big, but we need to structure the data in a way and provide access to the data so we can provide the content, the value from the data to the applications or to the analysis who need them without having to replicate that data. Intelligent technologies, which is here in the middle of that picture, needs to be integrated and available to the data, to the applications out there at a central place to make it easy to use artificial intelligence in the processes, in the data analysis, in the data analytics out there. And of course, have a simple integration for the cloud to have the possibility to offload the data into cloud scenarios where it's appropriate. Not all the data can go in the cloud, not all data should go in the cloud, but a lot of data actually can be better served if it's stored in the cloud. And particularly if you look at analytics, the end user can benefit from cloud-based analytics tool. So that, in essence, is the key message here. We have the big data. We want to have the big data because we have these business benefits which we can manifest, but we need a way to cost-effectively actually access that data and manage that data. Let me go to one example out there. It's a solution which is using a couple of components from our tool set out there. We're actually working with customers right now to refine that, to build this into an end-to-end scenario. It's about the high volume rate analysis. As mentioned before, we have more and more complex mass market products on the electric side out there. We see electric vehicles coming more and more into the consumer range. COVID-19 changed the behavior. So we need more and more possibilities to compare the different products, both for internal planning to see what the revenue impact will be, what the energy consumption needs will be, but also to support the customer. So in order to do that, you need to be able to not just have insights into the actual billing, but you need to be able to do a future simulation for the various different rate types for the individual customers using their particular energy profile and situation, and that leads to the need for mass simulation of the individual contracts with the various different energy consumption types, as I mentioned, under the COVID change pattern, or maybe if an EV would be in the house, and then allow to compare this data. So let's see if that video actually works. So that is a shortened video from that scenario. So here on that screen, we are seeing the rate analysis. It would obviously be performed on a regular basis in the back office for the different types of sets, and it would produce the billing details for all the different customers in the portfolio of the utilities, for the different rate types, for the different energy scenarios. Again, mentioning here the COVID-19 and the EV profile. So we have created here now data sets for all the customers for these three scenarios. So the regular scenario, the COVID-19 with an increased consumption during the week and an EV at home. And now we are moving here to the cloud-based data warehouse, where we are building the cubes in essence to analyze that information. So we have here all that information available, so different data. We can build here in the warehouse the cube based on the requirements for the individual analytics out there. And the good part here is to have virtual access to the data in the transactional system where we have the billing data. So you do not need to copy all this information out there, but rather consume it through these virtual data models to provide that information. And from here, we're going to the last step, the analytics, also in the cloud here, where we can see we have the different types of the analysis. Here we see here the revenue view for the different scenarios. Here we did this analysis simulation for a full year. So we did 12 months of billing for each of the customers for each of the 3 scenarios out there. And we're providing here the agent the possibility to compare that. Again, it's not necessarily about this particular use case, but to show that handling big data is obviously not just necessary, but it's possible today. And in our opinion, what we see from the customers we talk to, the better scenarios would include a common platform where we can build the applications on the same data platform where we can use data governance tools to maintain a safe and secure access to the data, and can guarantee the clean data and do the analysis across all the different data points. So with that, I think I come to the end of my presentation. Excellent. Let me go here to just the key takeaways. So data is getting bigger. I don't think there is anything new here. The business value is really what should drive the decisions. There is a large list of use cases. I'm surely didn't touch on all of those. And I went too far. And the common platform to help with a cost-effective value extraction. So with that, back to you, Andres and Dave.
That's wonderful, Stefan. Thank you very much. I think that you have provided sort of this smorgasbord, the buffet to the discussion here, and you're going to join us on the panel. So let me switch gears real quick, and thank you again, Stefan, for being with us. A very nice, powerful keynote. Let me introduce you to your moderator, who's a very old friend, old colleague from the Austin Energy days, who most recently had been with ERCOT as the Director of Systems Architecture and Strategy. And he is a super guru of all these things. And most recently, he decided to step down from ERCOT and retire there. So congratulations on his second or third retirement already. And he's now, or he has been the chairman of the Gridwise Architecture Council for a while. And again, old friend, David Forfia. David, are you there?
Yes, I am. Thanks, Andres, and thank you very much for that nice introduction.
Go ahead and run away with the panel. You know what to do. This is your cup of tea.
Well, I'll start out. There's a question in the Q&A. So the question from Dixon Wright, is that for the panel or is that for Stefan as part of the keynote?
I say go ahead and answer it.
Well, the question is the DOE orange button standards being utilized to exchange data between the stakeholders in the example that you provided, Stefan? And then what other standards do you see emerging? We might get into that during the panel.
Okay, maybe we can start here, but also think the panel can join in with that question. So the orange button is a specific country standard out there. I don't think out of the box we provide this since we have a global solution. What we strive to do is to make it easy to meet the needs for this regional standards to provide data access, whether it's for the interval data or other consumer data. Just think about, I guess everybody had to acknowledge these data security and data privacy rules again because Europe introduced that GDPR rules. So we introduced also the possibility to meet these requirements into our software. The same way we're trying to meet the other emerging standards as well. SIM, for example, is supported in our solution because it's now a global standard as part of IEC.
Thanks, Stefan. So I'm sure we'll touch on that as we begin the panel. So let me start out with some opening remarks. In 2010, and honestly before then, everyone's been talking about the coming data tsunami. The Economist published their data deluge article in 2010, and they claim to have coined the term big data and introduced it to a general audience. I'm willing to bet that Gartner and Forrester and IDC and pretty much every other advisory service would be willing to make the same claim. But in that article, they also predicted that the organizations that could manage that data well would do better than organizations that have not. They also made a 10-year prediction on how much data would actually be generated across the world. They said that by 2020, they would have 44 zettabytes of data. They underestimated that. IDC is currently forecasting that we're going to get to 59 zettabytes this year. So while they said there's benefits and risks to this, there are risks and rewards to dealing with that amount of data. And hopefully as we go through this panel and the distinguished people that are on it, we'll explore those with the questions we're going to ask. It's really my honor to do the introductions for the panelists. It's a very distinguished panel, and let me get through them and make sure that I get all the words out before we start the panel. So Evan Caron's our first panelist. He has a background that spans nearly 20 years in energy investment banking, derivatives trading, and investments. He is the founder and chief strategy officer at SwychtX, a venture-funded data management company focusing on energy, environmental, and critical infrastructure systems. Sonny Garg and his wife Julia, one of our other panelists, live in Chicago, and they're now begrudgingly becoming empty nesters as both of their girls have headed off to college. In 2015, Sonny launched the energy division of Uptake Technologies, the Chicago-based enterprise software company that has recently been named the third most promising AI company by Fortune in 2019. Prior to Uptake, Sonny was a member of the executive committee at Exelon Corporation, a Fortune 100 company, and served in a variety of senior roles, including as the CIO, the company's first chief innovation officer, and the president of Exelon Power. He began his career as public policy and government, including serving as assistant to Chicago Mayor Richard Daley and being appointed a White House Fellow by President Bill Clinton. He's currently a lecturer and executive in residence at the University of Chicago's Booth School and is a member of the 2008 class of the Aspen Institute's Henry Crown Fellows. Our next panelist is John Matranga, who is the Director of Business Incubation and Acceleration at OSIsoft. As part of the CTO office, he is responsible for the new market acceleration to expand OSIsoft's leadership position in emerging markets. John works to envision, position, and pilot offerings leveraging new and existing products, partnerships, and explore new markets, technologies, and business direction. With over 30 years of experience in IoT. John is currently focused on DER and IoT integration in the markets. He started with OSIsoft in 1990 and hasn't retired as much as I have, and has extensive experience in technology vision adoption as well as global services. His work in sensor-based systems has spanned decades and covers software architecture, design, development, and delivery by commercial software offerings and cyber physical systems. Before OSIsoft, John was part of IBM's T.J. Watson Research Center. He lives in San Francisco Bay Area with his wife and 3 children, and occasionally they stop by and visit. Brad Williams is a VP at Oracle's Utilities Industry Strategy and Innovation Engineering, responsible for utility operational solutions, including ADMS, DERMS, and grid analytics. Brad has more than 34 years of utility industry technology innovation experience. Prior to joining Oracle, he was an analyst at Gartner's Energy and Utilities Industry Advisory Services. He has spent the first 20 years of his career at Southern California Anderson and Pacific Corp, supporting T&D engineering, grid modernization, and asset management. He holds 5 patents, was recognized with an IEEE PES Prize Paper Award, and is a licensed professional engineer by the state of California. Our final panelist is Dr. Ziliang Zong, is an associate professor in computer science department and the site director of the NSF Cloud and Autonomic Computing Center at the Texas State University. He earned his doctorate in computer science from Auburn University with a Distinguished Dissertation Award and received the Texas State University Presidential Award for Excellence in Scholarly/Creative Activities in 2015. He studies energy efficient computing and systems, focusing on green data center, green software design, and green AI. Dr. Zong has published more than 80 peer-reviewed papers and received $2 million research grants from NSF and leading IT companies. He successfully led the development of the Green Code platform and the Green Soft platform, which generated large impacts on green computing research and education. He serves as the associate editor of the Sustainable Computing Journal and the co-chair of the IEEE International Conference on Edge Computing Scalable Cloud. Welcome to our panelists. And with that, I'll head off into the first question, which is, we've talked about the data tsunami. We said we're going to end up with nearly 60 zettabytes of data. In 5 years, the estimate has been missed by somewhere close to 40%. So the data deluge continues to be the data deluge and continues to expand. Now that we have even bigger data volumes and all the things that Stefan talked about during his keynote about what's keeping those things generate, adding more data to that set. Have we kept up with the wave? Is the wave catching us? Has the wave already washed over us? What's the vision for the future with even more IoT and OT devices gathering data? We'll start out with the first question going to Sonny. And Sonny, what are your thoughts, especially working for an IoT company?
Yeah, thanks. And Stefan, thanks for that presentation. It was really useful to ground the conversation. Yeah, so my thoughts are, I break it down into a couple areas. One is revisiting what Stefan was saying with regard to data is an enabler, right? It's got to be an enabler that creates benefit. And what over the last 8 years, 10 years, I've seen a lot of advances in our ability to manage data, to combine data, whether it's IoT data with enterprise data. Huge advances when it comes to AI and machine learning. So the data deluge doesn't scare me in terms of what we're going to do with the data and trying to create even value, create insights from that data. What really concerns me is more the back end of how that data gets used or how those insights get used. And while I think there's been a lot of advances in terms of how we manage data, how we use data, how we can get value from it, I think where we're really struggling and where companies are struggling are in 3 areas. One is understanding, well, what does that data actually, what value did it unlock? And can I measure it? And can I prove that investing in this actually improves my business? I still think that we're pretty far behind on that in many cases. The second area, I think, is what's the degree of change management and operational changes that are necessary? So if I give you a predictive insight as an Uptake, as a customer of Uptake, you don't have processes that know how to use a predictive insight. You generally are doing preventative or corrective maintenance. Doing predictive is a new thing. And so how are we actually changing the way we actually process the information and the operation side? I think that that is still something that needs to be heavily focused on. And the last area is, while we may love data, we may all say we love data, a lot of companies aren't driven to be data-driven companies when it comes to decision-making. We're still sort of dependent on hierarchies and titles and the way people, who are experts. And so I think that side is another side that needs to be sort of improved upon, which is, are we actually building cultures and organizations that are data-driven decision-making companies? So I guess, David, my takeaway from all this is I've been really impressed with the ability to do things with data. I've been less impressed with companies' abilities to actually take those insights and do something with them and turn those into the value.
Insights. John, you have 30 years experience with OSIsoft, who sort of grew up with being able to handle large volumes of data. What are your thoughts about keeping up with the wave and how to make sense of everything that's coming?
Yeah, I think Sonny hit on a number of things that were perfect. When you look at the overall volume of data, we can collect the data. As a matter of fact, most of our customers are dealing with subsets of our data when they get into the analytics. The real question is, as Stefan pointed out, where's the value coming from, and how's that complexity going to change over time, right? So whether I'm dealing with data that's got the scope of an edge or an enterprise or a trans-enterprise in a supply chain conversation, that's really where the volume of the data really gets to be interesting, and the governance that comes around with it. So it's not only the governance for company-to-company interaction or the personal data, as Stefan was talking about in the privacy parts, but also the governance in the relationships between the entities, right? And if I have a contract with Uptake today to look at my data and do some analytics on it, what happens tomorrow if I switch my provider, right? That's providing my value-added expertise. And that's where this complexity of the relationships, I think we're still in the early days of that. Capturing the data, storing the data is the easy part. It's gaining the value from it that I think is the real challenge.
Good points. Brad, you have lots of experience dealing with T&D field crews plus Oracle's full offering. How does what Oracle brings to the table help with the dealing with the volumes of data and sort of the wave that's coming in, and tie to what the framework that both Sonny and John put together?
Yeah, thanks, David. And I appreciate the remarks of my fellow panelists and the keynote earlier with Stefan. So in my utility days, we were putting in digital T&D devices, controls. We were replacing the electromechanical devices with digital, which came with an exponential growth of data to manage, a number of set points and those types of things. But what I found was, until we actually tied in the processes to leverage that data, it was simply dark data, just like dark fiber, data that was available but wasn't being used. And Stefan mentioned the digitalization of the data, and that's absolutely key to drive value. Is when we can bring the entire end-to-end process, that the data is being collected and it's being automatically populated in these critical core operational systems, whether they be asset systems or operations, ADMS, EMS, other applications. That's what's really going to drive the value, or richer analytics to expose potential problems in the future. And when we start talking about the low costs of sensors and the low cost of communications, I know we're going to get into other IoT type of questions later as well. This is just continuing to grow very quickly, and again, it's like just because we have the ability to collect it doesn't mean we're going to get the value. And it's absolutely key that we have structures and processes to leverage this data to actually drive the operational and business value from that. And that's what these systems and applications that we can support. Other things like stream analytics, other things I think we're going to be covering later in the panel, even like things like distributed process control, where we can process some of this data at the edge and then bring back the critical information back into the enterprise and leverage that for future applications as well.
Thanks, Brad. That leads sort of to the next question, right? Storing all this data, as we saw in Stefan's keynote, isn't free. I'll start out with a research question. Dr. Zong, you've done a lot of work on green AI and the green data centers. What areas need more research as the big data wave starts to hit us even more, that investment would help us deal with this data and start to extract the value?
Well, first of all, I want to thank Steve's keynote and all the points the other panelists make. It's great from academic point of view to hear about the real challenges from industry. And, our lab has done research on the big data analytics and stuff like that. Our thought would be, we all say like, big data is not free. In my point of view, it's not just not free, it's expensive, right? The data is expensive. And in terms of the data, we're talking about storage, transferring, we're talking saving data, we're talking about, transferring data, we're talking about processing data. If you think about these three phases, storage probably is the cheapest part now because the storage component really getting cheaper and cheaper. But the bandwidth, right, to transfer the data from the edge side to the data center side, to the cloud side, and also the processing of these using AI and machine learning algorithms is getting more and more expensive, right? So I think there's a gap from the academic to the industry. Is I have heard a couple of panelists talking about the challenges, like how do we, bring values, right, to our customers on that. From academic point of view, it is hard for us to get the real data, right? So like we have algorithms, we wanted to help with that, but we need some sort of, communication channel with the industry so that we can get the real data from your customers so we can bring the real value. I understand the privacy is a big issue, right? On that, in the previous collaboration, we talked to the different companies, and privacy is one of the important things. So I just want to know more about, how do we collaborate more from this and how do we do that, right? The other thing from the big data point of view, we have done some research. We found that each application scenario probably is different, right? And there is, probably there is not a magic solution that fits all of that. And then maybe the big data application, or, it's like you need to combine a couple of different algorithms to improve your big data application, step by step, or, combined fashion on that. Okay, so that's just my point of view on that. Hopefully we can build some collaborations.
Thanks. It's always good to hear the research perspective. Evan, if you go through and take a look at what's coming from the big data perspective, sort of what other use cases and other examples can you bring to the panel to talk about how to get value out of the amount of data that we're collecting, and how does your technology and SwychtX technology sort of lend towards that?
Yeah, and I appreciate being included in this part of the conversation. I think, obviously a lot of the conversation and discussion is about the volume of data. One of the main things that we focus on is not just the volume of data, but the validity and veracity of the information, as well as the ability to really trust the information that we're using all these machine learning models on. How do we build trust and transparency in information gathering, information systems, and have validation closer to the actual information process. So that's one thing. The other thing is there's good data and there's bad data. There's data that informs models. There's a lot of assumptions that are made in machine learning and AI models. So there's a question of what data is more valuable, and data that's more valuable is data that is harder to come by, and data, we've got a lot of data that everybody has access to. Well, that's not very valuable. But data that is not very accessible, to increase fidelity of models, that could be much more exciting and interesting from that perspective. I think one of the other things that we don't talk about is context in information systems in general. As we talked about before, a lot of the information comes from individual assets or individual meters or individual systems, and they don't really have the component, a lot of the components that are required in terms of time, in terms of situational awareness and other information associated with those data streams or those data types. And I think one of the really interesting things that we focus a lot of time on is around building context around critical information. So time, location, device identity, device type, device reputation, the focus on what contextual and metadata is associated with that information to make it more powerful. One, so that you're not having to call other resources and other databases to be able to make deterministic outcomes from that information, but also at the same time, we feel like it's really necessary to input or have data have relative value between one data stream and its metadata as well. So that's another construct. And the third one is around data collaboration. One of the things that we see around big data is everyone's thinking big data is like the next oil or the new oil. Everyone wants to covet it. They want to hold it. They want to share it. One of the things that we notice and recognize is that, as we talk about transitioning energy systems, critical human infrastructure systems, essential data, power plants and water, distributed energy resources, et cetera, we recognize that there's going to be significant limitations for everyone controlling their own data resource without giving the instructions and tool sets and or capabilities to have multi-stakeholder collaboration associated with those data sets. And I think until we get there, we're going to have this kind of big data tsunami as just kind of more and more redundant information that basically sitting on multiple servers that exist across different stakeholders, but also kind of this concept and issue around data access and accessing multi-party data systems. So the things that we focus on are building or trying to build infrastructure, permissioning infrastructure and data sharing infrastructure that enables the sharing of critical information between multiple stakeholders that enable more, just more awareness and still maintain some of the value add or IP or assets in terms of asset equity or data equity, if you will. And that's where we focus a lot of our effort and time on. And so kind of thinking about building data commons in all of these systems is kind of where a lot of our time and energy is spent.
Thank you. Stefan, as part of your keynote, you did an excellent job of teeing up all the use cases, or at least some of the use cases, because you weren't going to get to all, about how you can derive data from the value from the data that's being collected. An excellent question has been asked in the chat window that said, okay, part of this starts with the data, but culturally there's an organizational change impact to it also. What have you seen with your breadth of experience and the breadth of customers that SAP has to work with that helps make the transition from being, a shoot from the gut company to a data-driven culture?
Yeah, thanks, David. And it's really a great question, which the audience asked here. To what Evan just said, I mean, that is one of the key aspects, trust. I mean, why would you even look into data if you're not sure you can trust the data? Why would you look into the data if it's already outdated by the time you finally get access to that data? Why do you need to access the data if every time you want to use some form of data, you need to use a different tool? So while there are many aspects to the fact how to get to a data-driven culture out there, I think there are certain things which technology can help to make easier to adopt a data-driven attitude anyway, to come to a culture. I mean, there's more to that one out there, but we need to make it easy. We need to bring the data to those consumers within the organization to help them to maybe even go to be able to play with the data in a reasonable fashion, to guide them to use the data, to help them to see that what they're using is true, it is relevant, it is still up to date. It is also guided out there. I think, Sonny, you made the point earlier. It is about how to actually extract value. Do we even know how to extract value? Does everybody in the organization have to become a full-fledged data scientist who understands perfectly well how data needs to be combined and constructed so you can extract the value? That would be too much. We need to simplify the access to that in order to really get to this data-driven culture. It needs to be as common as any other tool we are using, any smartphone we are using today to use data. That is what we need to do. We need to make it as simple as that.
David, may I jump in on that?
Yeah, be my guest, Sonny.
Yeah, I 100% agree. And I think, when I was CIO at Exelon, I loved the idea of big data platforms and, what Predix was doing or what C3 or what people were trying to do is create these giant places we can manage all this information. And I think we've gotten better at that. But I think to Stefan's point, part of what I think we've got to really focus on is simplicity and start with things that work, that people can get used to using, right? And not overshoot what it is. And so it's interesting at Uptake, we've sort of taken some, I love what we do, but to a certain degree, we've taken some steps to say, look, let's just make it simple. Let's just make it and focus on like getting it into somebody's hands so they can use it and they can see value, right? That begins to change the mindset as to how you actually use insights and data. But if you are worried about the precision or the accuracy of the insight, then you're just going to feed the skepticism of the user, right? And so I think you have to start with simple. If you're going to make that culture change, make it easy for somebody to be able to use, make it easy that it fits into their process and the way they make the kind of decisions they need to make on that given day. You're just making it easier for them to make better decisions because you're providing them better data and insights. And I think that's how you start building the culture. And if you go too complicated, you run into lots of different, I think, risks in terms of like, how are you managing the data, the veracity of the data, the integration of the data, the accuracy and the precision of the models. And so I think you've got to start with things that almost work out of the box to build up that confidence. And then that just sort of snowballs on itself.
Thank you.
Yeah, I think just a quick comment on that. I think the part of the trust and the culture on the data is important, right? So start simple and having wide visibility to the data before it becomes information, before it becomes knowledge, before it becomes actionable, right? Because as you build up that tree or that staircase, you have to get more and more alignment in your organization, right? So first thing is, you come to a meeting, everybody's working off the same data. That was easy to access, right? Not that's in some siloed system that the person coming to the meeting has their gift. Here's my data for the meeting, right? You need that data to be accessible to everyone so that there's a commonality around that. And then as you build up that staircase, you build your acceptance of the business processes and the outcomes that you're after as you value add your data. And I think that's the really important part, is the accessibility, as Stefan said.
Yeah, can I follow up with a real world example that happens in my case? Because we have a lot of utility companies here. So we're in Texas, right? So we spend a lot of water, the water bills just go up in the summer. So that happened to me once as a customer, which is, I found like 1 month of my water bill just like 4 times of the regular bills. When I found that out, it was too late. It's just 1 month later. Then eventually I found out there is one head in the sprinkler system leaking badly. And then you don't know that until that you get a bill like 1 month later. I was thinking like, if you could use the big data early and often, right? Not just like, I think Brad talked about the dark data just sitting there, you just collect this data or just don't use that. Or just give early warning to that. Oh, I found that maybe your water bill like goes up, abnormally, you want to check your sprinkler system, something like send a text message to your customer will be a happy customer, right? So something like that. And then I think that's what Sonny said, right? You make a small one, that's actionable, that's something, make your customer application, the customer happier, right? And the real application scenario. That'll be a good starting point.
Well, that's an excellent tie-in to our next theme. There's a lot of computing that's going out on the edge, and the data is being generated out there. In some cases, it can actually be acted upon at the edge. So with the edge computing coming into play, how is that technology going to affect what happens on the utility grid? Are we going to get to the point to where you can actually, at the meter, determine whether or not my computer and my camera that's going through and hosting this webcast is the biggest electric draw in my house, or is that something that's too far out? Is that technology on the horizon? Sonny, what do you think?
Sorry, I was muted. That was very profound what I said. Now I've forgotten it. Yeah, like, I mean, I think the edge piece is pretty nascent, and we're getting there. And it depends on how you think about and how you define edge. You know, there's one element that says, look, it's just moving the computing down so you don't have to bring it up in the cloud and send it back in, right? There's value in that in lots of different ways, particularly even on the cost side. But when I think about the grid and the ability to actually in real time be able to optimize power flow, that's really the holy grail when we start thinking about decentralization and distributed assets and stuff. And I still think we're a ways away from that. What I do like about the edge piece is it's a new frontier. It's exciting, but I think we are at risk of making the same mistakes of getting really excited about the technology and not taking a step back and thinking about, well, what's the value here? What are we really trying to solve for when we're talking about edge computing? And I think on the grid, to me, it's more about how are we going to optimize power flow in a very dynamic distributed world in order to maintain reliability than it is necessarily when it comes to the edge and better, for Uptake to be able to give you a better insight on your wind turbine. That'll be great from an edge perspective. I think we're closer to something like that, but the optimization of the actual power flow, I think we're a ways away from.
Makes sense. Stefan, you talked about it on your use cases at the beginning about things happening to deliver better services using that distributed computing, and then the value of taking it back within the data warehouse to do the longer term analytics. What do you see the split being between what happens at the central or aggregate data level and what happens out at the edge to be able to deliver more value to the customers?
Yeah, it's a very important question. As mentioned before, we should not just look at edge computing or edge data management as a silver bullet, which now suddenly can solve every problem because we haven't really understood it. So we think it can do everything out there. I think there is a great value which edge computing, edge data management can actually bring to the overall business processes. But to the point earlier made on the panel, we need to understand what kind of value do we want to achieve overall. What is the end-to-end process here? What is a place for each piece of technology in there? Can I really validate the data at the edge? Great, wonderful. Can I manage, can I locally organize data, organize my process at the edge to improve value? Great, let's do that. But let's not, for example, move data from a central location to the edge so the edge can do more. I think that would be the wrong design to artificially inflate the edge out there. We need to use the edge possibilities in order to minimize the data we actually need to either store centrally in an on-premise solution or in a cloud solution or wherever. If the data is really just relevant for the moment in time when it is being created, when it's only relevant there, when it's only in that context being useful, then let's keep it there. Let's keep the data in there. Let's have the knowledge there, and we can do more today than we could do even 5 years ago. Bringing, for example, into the substation intelligence to manage the substation more closely to where the data occurs, so we don't have any lag time for critical processes. But again, that is probably not the silver bullet for each and every problem out there. So again, we need to step back. We need to look at the overall process and the overall value we want to extract.
So I think the edge side has a lot more challenges. For example, we have to consider the limited battery on the edge devices, and we have to consider limited CPU and memory on the edge side. And so that means the software running on the edge side, I think, will be totally different with the software you run on the cloud side with unlimited resource and power there, right? So I was just thinking, just take one example as, like in our community, a lot of homes have the, camera, right? So they have the smart camera, and then I found that most of the camera just, you can store the videos, right? You can store the videos for like maybe a week or something, depending on your storage capacity. But most of the videos are just non-interest videos, right? At night, you run 24/7. So I just, if you look at the videos on that, what's interesting is when somebody show up in your door, which you don't recognize, then you should run something really high accuracy, very good AI algorithm to do that. Other than that, at night or something, if a cat showed up at night or dog showed up at night, then that's less interest, but still of interest. But most of the cases, you find that the video camera just store a bunch of information that's not useful at all. There's nothing happening. I'm thinking if we could run, so one of the ongoing research doing in our lab is to, how to develop the efficient AI for the edge devices. That's very, very important. What if we run some AI algorithms, like we can run some very low cost AI algorithms to, to save the cost, save the storage, and then most of the cases, and then when something interesting happens, then we can run some high accuracy AI. So that will probably just make your video, you can save up to 30 days, right? Because most of the non-interest video just automatically filtered, but at the edge side, you don't have to send that back to the cloud, all of these, right? So I think this is just as you use the home camera. There are many other industry cases, like if you're using, I know a lot of industry are using the monitors and sensors at the edge side to do the streamed video to watch the operation of the engine, right? Before the engine failed or something, you see something sparkling or some warning sign. So those, most of the cases that you can do we are trying to develop something called double nets, or using a small big net. So those kind of ideas. So we developed the AI, efficient AI for the edge side. Those will be probably a lot of application scenarios applicable, to maybe to industry.
Good points, Dr. Zong. Evan, everyone talks about digital ledger technologies, and depending upon how the implementation happens, it could happen at the edge. What do you see happening with things like blockchain going out to the edge if you're going to go through and do proof of work? How would that fit into a solution like this?
Yeah, I think that's the blockchain is interesting because when you think about the architecture for developing edge level nodes to do some form of validation, encryption, cryptographically secure proofs directly at or near the device. I think you run into a lot of the same problems in terms of compute bandwidth, battery bandwidth. Raspberry Pi can only do so many things. The cool part about what we're talking about and what we'll work on is that, while we're not streaming video data, we're streaming, individual bits of kind of text-based data, right? In terms of, I would say low bandwidth information, right? In terms of sensor-based information on or off, state channel, state of charge for certain resources. I think one of the opportunities is to be able to run, and again, depending on blockchain solution, you can run a full node on an edge device and use that information to either inform what information is required to publish to a ledger-based technology, or establish some sort of logic that keys into kind of creating data normalization at the edge, so that there's a more robust infrastructure and framework for the information that makes it to a ledger as well. The validation can be done at the edge in terms of additional logic that can be basically distributed down to those resources without necessarily requiring cloud-based resources. So, there's not the conversation of proof of work and other stake-based protocols that allow hardware-based computation to do edge-level analytics and edge-level compute for kind of ledger-based security infrastructure. I'm less involved in that component. The kind of proof of work element for blockchain infrastructure is slightly at antithesis to some of the core understandings that I have, or core ethos that I have around reducing overall energy consumption from a data perspective. It's going to happen. I'd rather find other ways to build consensus and distributed systems for blockchain infrastructure. But what I will say is that there is a lot of work that's been done on developing kind of that edge level node, IoT, self-validation, self-audit And I feel like that can be done with kind of low compute resources using IoT-based reputation, right? So instead of having, again, we're getting into ledger technologies and permission versus permissionless infrastructure, which we can probably spend hours and hours on. But if you're able to be able to do the right type of edge level device identity, and you're able to require those edge level devices to do some kind of work, whether it's stake-based work, whether it's reputation-based work, or whether they're doing edge level based validation, I think that could be a really interesting way to use some compute resources at the edge. I think we are still definitely early on that. I think, obviously the whole coordination and orchestration of downstream energy systems for resiliency and managing power flows is something that we need to get to pretty quickly. But as far as the simple stuff, which is really looking at what I'd call kind of lightweight Raspberry Pi type of edge devices to do sensor-based validation and leveraging kind of a reputation score for those devices, I feel like we can get a lot of work that's needed done at the edge and not necessarily rely on heavy base cloud computing to do some of the simple stuff, right? That's kind of where we focus.
Makes sense. Brad, as a professional engineer who works for a large company that does ADMS systems that control DERMS, what do you see coming with edge type devices?
So great question. And with the growth of distributed energy resources, it is driving more inverter-based technologies versus central power plants. And from a power systems perspective, that means we don't have that spinning inertia of the central power plants because the inverters don't have that. That makes the grid less reliable. Okay, but appliances that we put in our homes today or in buildings are much smarter and frankly IoT enabled. I bought a refrigerator, freezer, thermostat, and hot water heater, electric hot water heater. I didn't buy them because they were IoT enabled, which they are. I bought them because they were cost efficiency from an engineering standpoint. It's like, oh, this is what I'm looking for. Get it home and said, oh, I have IoT enabled devices, which means I have the ability to change the settings and actually respond to grid constraints. So for a much lower cost to respond to frequency and voltage, sense and respond, I can provide higher levels of reliability than putting in infrastructure to displace that loss of the spinning inertia to accomplish reliability. So there's a tremendous opportunity to leverage those types of technologies. And then on the same way for like electric vehicle charging, which by the way, electric vehicles are growing at a very fast exponential rate. Fastest selling car in California is Tesla Model 3. Which means if somebody goes and plugs in their car during a hot summer day when the air conditioning is the highest, we've just doubled the capacity for those places, which means we're going to overload the service. So if we can be smart about that, to say, okay, we're in a peak period at peak power time, and let's be smart about how we charge. Let's allow charging, but reduce the or increase the time to charge so that it has less impact on the grid and higher reliability, then all customers are satisfied. That requires deeper customer engagement as to grid operations, but all of that driven by data and some of the things we've already discussed.
Great points. You brought up the things that are now starting to change at the speed of the consumer: electric vehicles, smart appliances, Alexa in the home. John, with this amount of technology going at the speed of the consumer, not at the speed of the regulator, what issues do you see driving that space, and how's that going to affect the grid?
That was a great comment. I missed it. I think that's a perfect segue. The consumerization and the consumerization technology working its way into the grid, I think is very exciting. connected EV chargers, connected devices within the home. That all is enabling and good. The real scary part about that is the security piece, right? Because if we're, professional engineers, PEs certified, we're looking at problems holistically and taking an approach to it. Whereas if you take a point solution and just happen to apply it to a different domain, then the assumptions and the engineering that went into that first domain, may not be valid in the second domain and may miss those key things, right? So it's one thing to have an EV charger that you can spin up or down. It's another thing to say, well, how does that interact on the grid from a security standpoint? And what would happen if that EV charger got, compromised in mass, right? We've seen that happen with some of the smart devices within the homes. So it is concerning, and that's where having standardized protocols that are certified help, right? So by having something like 2030.5 and other protocols that allow for the interchange of the data in a way that's managed for the purpose of the outcome, I think is the important part, to layer that in. So it's not only the consumerization and the access to these objects or these assets that's important, but doing it in a way that's appropriate for the target domain.
That makes sense. So Stefan, how does a company like SAP become agile enough to adapt to things that are changing very quickly at the consumer edge, especially with not only the technologies, but regulations, because you brought up the GDPR regulations. How do you adapt to those changes quickly within your products?
Yeah, excellent point, and particularly around the speed of consumer, which I think is like the data exploding at an exponential rate almost. The expectations of the consumer and the speed how they change on the behind the meter side. Just on the smart home, I think we are expecting the next couple of years, a couple billions to be invested worldwide in smart home products, whether it's around security or convenience. So since you asked what are we doing as SAP to stay on top of that, I think key is here to stay flexible. You cannot provide a single solution or a single set of services in essence, which says, okay, this is how consumers have to be dealt with. The consumer is changing way too fast. The regulation is changing. Today it's security on the data. Tomorrow, as John pointed out, it's also security for the devices to ensure that no outside party illegally can hack into the equipment, while at the other time consumers are happily sharing the innermost details with platforms in order to communicate on social networks, and still trying as vendors to keep them safe. So what we're trying to provide here is the right tool set, the right out of the box functionality, which you still can then configure, trying to avoid the word customize, to meet the needs of the consumer. Brad, you brought this example, a great example about the charging during a peak day or peak event for the customer. And I think maybe what we need to do here is, in order to work at the speed of the consumer, is to address both sides. The consumer bought the car, invested in the charging infrastructure and whatnot. He needs a car to go somewhere. So when he plugs it in, I think he's expecting that after a couple of hours at least, he has a decent amount of range in that car. The utility wants to make sure that the grid stays stable, and not just this consumer, but the whole neighborhood stays under power in there. So a central control is probably not not sufficient here, because that consumer may actually have a battery and solar panels on the roof, which can feed directly into the car without actually adding strain to the grid by tapping into those resources locally. So here, I think we need to really, again, back to the big data topic. It's not about one part of data. It's really bringing the data together to create these value cases where a utility, for example, can deliver that convenience to the customer of managing the charging effectively and efficiently, while at the same time taking care of the needs of the distribution company to keep the grid stable out there. This is a type of platform technology, which I think which goes back to what I mentioned in my presentation, is what we need to provide. So these elements can be plugged in, coming from different sources, and addressing the different needs of the different players out there to achieve an overall goal for both sides.
Thank you, Stefan. I'm going to try to turn to the audience questions, because we do actually have a question on standards on demand response. And since I work with the Open ADR Alliance, I'll go ahead and try to phrase the question appropriately. Demand response, how does the panel see that being executed, especially with standards like Open ADR? Because it might be able to get you megawatts easier than getting megawatts in some cases. It certainly did around 5:30 in parts of California earlier this week. So the question, how do you see this being implemented? What are the impacts going across it? How do standards like Open ADR and 2030.5 play into that? I'll open it up to any of the panelists to answer.
I'll jump in, David. So standardization is really important to be able to take advantage of things like consumer technologies, demand response. And when we start talking about demand response in terms of a grid side resource, it's very important that we integrate that into an ADMS type of application. So it can be part of a core business process, not only for supply side, but also for grid side. And it's standards that enable us to do that. And the other aspect of that is understanding that there is some deterministic control to traditional SCADA assets in the substation, and some non-deterministic response to things like edge devices, like demand response or smart appliances and those types of things. And to be able to integrate them and provide a secure environment, but understanding that some things are slower to respond and some things are very fast to respond. So that's going to be very key when we start talking about the models and managing that. But to the point of the question, is standardization is actually critical for us to be able to adopt that safely.
Thank you. Well, we're getting near the end of the time, so I would like to thank all the panelists for their time and their great answers. Stefan, an excellent keynote to go through and start the panel overall. And to all the questions we got from the audience, excellent questions. I tried to weave them in as we went through the panel. Hopefully I got to them all. I believe that brings us to our closing comments from our host, Andres.
Hey guys, good job. Congratulations. Thanks everybody. Well done. Kudos. Difficult topics. You know, I'll say a couple things before we go away and leave the audience pondering on this. There's a rumor out there that a little company called NVIDIA, which has the largest market cap of any semiconductor company in the world now, is about to acquire a little company called ARM. What would happen to this whole conversation if somebody like NVIDIA, with the brilliance of NVIDIA as a GPU microprocessor company, were to buy ARM, and all those meters and devices that have ARM processors were now under the tutelage of NVIDIA, collecting data and processing? But do you think that would accelerate things or slow things down? Anybody?
Both.
Both.
Maybe it would help to play some computer games on the meter, thinking about the NVIDIA graphic cards out there. It certainly, I think, would help to bringing that type of technology to edge devices, as we talked before, to make more use of the location where that device already sits. So I think it would help with and speed things up.
Yeah. So
yeah, I would agree with that. Sorry.
Go ahead.
No, I would agree with that. I think bringing in folks from outside the industry is a good thing. You know, I just think that that's going to drive innovation and they're going to see things in a new way. And I love the idea of somebody coming in who's going to bring a new way of thinking, because the problems we just talked about are pretty complicated. And I think having different mindsets coming into solving those is going to be a huge benefit.
Right. I don't know, also another topic that I wanted to do, and I know some of you got to go, but just 30 seconds. There is 3 things going on that are really important that are going to impact what we're doing. One of those is all driven. These 3 things are just actions by 3 large players trying to create a new paradigm using 5G technology. So you're probably familiar with the fact that Amazon, SpaceX, and Dish Network are building a low orbit nationwide coverage of broadband using 12 gigahertz wireless technology. Amazon has committed $10 billion to this. So within the next 5 years, everywhere in the United States, you'll have 5G 1 gigabit per second anywhere in the United States in broadband. What do you all think that would do to the amount of tsunami data that we'll be collecting? More data or less data?
Way more data.
Much more.
So I think that you all agree, right, that there are some things that are nascent on where we're at, but the opportunities are tremendous. And if the amount of data and network capability gets cheaper and bigger bandwidth and with lower latencies, all the real-time use cases can be collected in terms of data. The question is, what do you do with all that data now? So Sonny just basically came up with 3 products in his head right now.
Well, Andreas, I think it's important to go back to, like, who's got the incentive to do something with that data?
Right.
So I think that that's going to be really interesting to see the types of players who want to come into that space and solve problems that historically, we just keep coming back to. Well, the utility's got to solve with the utility. I'm not sure that's going to be the answer in the long run.
That's right. No, I agree. I think the end user somewhere, right?
Yeah.
Yeah, I think that will be an additional possibility for utilities. But to your point, Sonny, somebody will grab this opportunity. Somebody will meet the needs, because additional data, additional technology creates opportunity. Apple did that not even 15 years ago with the iPhone, and conquered the market, an area where they never were present before. So this new technology will provide this type of opportunity for someone. The utilities can play in there, and I think us as providers, as engineers, and as supporters in that industry need to help there to give them the right starting point. Whether they choose to do that or not, that is up to them. But I think there is a possibility here for them.
Absolutely.
Anybody
And
I think coming back to Stefan's point in his keynote, we saw this 20 years ago in the early days of sensing, or 40 years ago in the early days of sensing and automation. In the early days, you just build up silos of information, right? So I think there will be an explosion of information with many more silos. It's about the integration of this data to solve cross-silo problems. That's going to be the important part. And you can't, you're not going to be able to bring all that data into one location. It's about the integration of that. So I look forward to those challenges that we have coming down the pike, and that data governance and fine granularity of sharing that data across these boundaries. Imagine your ad profile, your ad preference profile, but applied to your energy data. Right?
Absolutely. All right, I'm going to stop recording. Thank you. You're welcome to stick around or take off if you need to. Thank you for the audience today. Recordings will be on the CMG website in a couple of weeks. Thank you very much for participating with us today. I'm going to start recording now.